This video covers cross-entropy loss. I'll provide an overview of loss functions in general, discuss the intuition and equation for computing cross-entropy loss, and then work through a case example to see this computation in action. We use loss functions when we need to determine the distance between predicted and true output values, and we do so using conditional maximum likelihood estimation. When computing conditional maximum likelihood estimation, we select our weights and bias terms such that they maximize the log probability of the true valued instances in our training set, given our observations or feature vectors. By maximizing the log probability, we end up with a negative log likelihood loss, which is more commonly referred to as cross-entropy loss. Cross-entropy loss is generally the most common loss function for classification tasks, and at its core, it just measures the distance between the probability distributions of predicted and actual values, which you can see from the equation. For every class, you multiply the actual probability that an instance should be labeled as class C times the log of the predicted probability that it should be, and then you sum up all of those products and take the negative of that sum. Lower loss values are better, and higher loss values are worse. So when you have a big distance between your predicted and actual values, you generally have a high cross-entropy loss, whereas when you have a small distance between predicted and actual values, you have a lower cross-entropy loss. In the last video, we performed sigmoid classification with the example you see here, and we predicted a class label of sarcastic. If you're watching these videos out of order and you're not sure what I'm talking about, you may want to review the previous video introducing a basic logistic regression classifier. So let's go ahead and say that the actual probability that this instance is sarcastic is 1, and the actual probability that it's not sarcastic is 0. That's because we have the real label, so we don't need to guess at anything. But remember when we generated our predictions, our sigmoid classifier output a probability of 0.96 for the sarcastic class and 0.04 for the not sarcastic class. Now for easy reference, here's our cross-entropy loss equation. So to compute our cross-entropy loss, we'll go ahead and take the actual probability that the instance is sarcastic, that's a value of 1, times the log of the predicted probability that's sarcastic, which is a value of 0.96. We'll also take the actual probability that the instance is not sarcastic, which is 0, and multiply it by the log of the predicted probability that the instance is not sarcastic, which is 0.04. Then remember, we're taking the negative of the sum, so we'll have negative 1 times log 0.96 minus 0 times log 0.04. We find that this equals 0.02, which is a very low loss. Now to contrast, we can pretend our predicted probabilities were reversed. So what if our predicted probability for sarcastic was 0.04 and our predicted probability for not sarcastic was 0.96? Well, if that's the case, we get a very high loss that's actually above 1. So that would indicate that our classifier was performing extremely poorly. If you tried to take the log of 0, for example, if our actual label was sarcastic, but our classifier was 100% without a doubt convinced that the predicted label should be not sarcastic, we would actually end up with a cross-entropy loss of infinity.